In this video, I'm going to show you how to find confidence intervals and how to conduct a hypothesis test for proportions. For this exercise, we are going to be analyzing a very famous dataset called the Framingham Heart Study. Let's take a look at it first before we do anything further. So I'm going to navigate to Libraries, SAS Help, and this dataset is called Heart. I'm going to maximize our workspace. And we're going to be paying special attention today and analyzing the BP status column. This column is a categorical interpretation of somebody's blood pressure. So if they have high blood pressure, it will read high. If it's normal, it will read normal, and so on and so forth. So this is the column we're really interested in here. And of course, because we're going to be computing a confidence interval and a hypothesis test for proportion, it makes sense that this column is categorical and it's not numeric. So let's go ahead and just close this data set. I'll bring my tasks back. And for this particular type of calculation, we are going to use a program that we wrote for you in the class. So we're not going to be using a task in SAS Studio. So let's go ahead and open that program. To find the program, we're going to go to Server Files and Folders. Under Files, we're going to go to My Shared File Links, MSLA1, and SAS Progs. And you will notice a program called CI and Hypothesis Proportions. So we're going to go ahead and open that. Now the program is pretty simple to use. You're going to fill out the settings for steps 1 through 5 and then simply run it and interpret the results. So it's pretty straightforward. Here you'll see step 1 is the name of your data set. In my case, I'm using sashelp.heart, but you could be using any other data set either in the SAS Help library or in the datasets library that we use in class. So the way you enter this is the name of the library, a dot, and then the name of the data set. So in here we have sashelp.heart. Step 2 is where you provide the name of the column for the variable that you want to analyze. And so we already know that the column we're interested in is called BP_status. If you aren't sure of the name of the column, you simply have to go open up the data set under Libraries and look at it like we just did and look at what the column is named. And you'll go ahead and put that here in step 2. In step 3, we are wanting to enter here the specific value that we are evaluating. So for example, if I'm trying to perform a hypothesis test or trying to calculate confidence intervals for those people in the study that had normal blood pressures, that's what I'm going to put here. So in my case, I have normal. If I was interested in analyzing people with high blood pressure, I'd put in high. So whatever the value is that you're interested in analyzing is going to go here. One important thing to mention is that this is case sensitive. So if normal has a capital N in it in the data set, I have to put a capital N in here as well. So you have to be very specific and exact here with the value that you're looking at. Now, step 4 and 5 are used depending on what you're trying to calculate. So if you are trying to perform a hypothesis test for that proportion, in step 4, you are going to type in the proportion for your null hypothesis. So for example, if our null hypothesis was that 40% of all of the patients in the study have normal blood pressure, then you're going to go ahead and put in 0.4 here. It's important that you use a decimal here and not 40 and then a percent sign or something like that. You really want to put in 0.4 if it's 40%, 0.56 if it's 56%, and so on and so forth. You really only need to change the setting if you are performing a hypothesis test. If you're just going ahead and finding confidence intervals, you can just leave this at whatever it's set to when you open the program. But there does have to be a value here. It's just ignored or not used if you're just finding a confidence interval. Now in step 5 is the opposite. So if I'm just finding a confidence interval or I'm interested in finding confidence intervals, I'm going to go ahead here and put in the confidence level that I'm interested in. Generally, you're looking for either a 90, a 95, or a 99% confidence interval. So here, for example, I have 95. Here, in this case, do not use decimals. So if you want the 90% confidence interval, just put in 90. If you want the 99, put in 99, and so on and so forth. Do not put in a percent sign. Just the number is fine. And that's it. Again, if you're not finding a confidence interval and you were just performing a hypothesis test, you can just leave the setting in step 5 alone. But again, it has to have a value, but you could ignore it if you're just doing a hypothesis test. Now, if you're doing both, then you fill out both steps 4 and 5. So it really depends on the situation, what you're trying to calculate. So that's all that you set up. And once you have all of this set up, you simply run the program. You don't edit anything below step 5. So before I run it, I just want to review my settings here. I have my data set correctly. I have the column name set that I want to analyze. In this case, it's BP_status. I have the particular value that I'm interested in this case, people with normal blood pressure. And I have my null hypothesis and the confidence level that I'm interested in finding. Of course, you have to set these null hypothesis and confidence level settings appropriately depending on what you're trying to find. That's beyond the scope of this video. That's something you should have learned in your course. So I'm going to go ahead and run this. And when I run it, I get some output here. Let's maximize my workspace just so we can read this together. So really what you're interested in, depending upon what you're trying to find, is either your confidence interval or the result of your hypothesis test or your p-value. So here, under where it says confidence limits for the binomial proportion, I have my lower confidence level and my upper confidence level. So I see here that my lower confidence level is about 39.8% and my upper confidence level is about 42.4%. So here's your lower and upper confidence limit. So you can now, using this data, state your confidence interval. And remember, this is for the 95% confidence level. So I can change that if I want back in the code, but in this case, I wanted my 95% confidence level. And then below is your hypothesis test results. Now I have 2 different p-values that I'm interested in looking at. If this were a two-tailed or an exploratory hypothesis test, I want to take a look at this last variable here where it says two-sided, and this output says 0.0930. So my p-value is 0.0930. Therefore, because that is greater than 0.05, I would fail to reject my null hypothesis. That is, of course, if I were doing a two-sided or a two-tailed or an exploratory test. If I were doing a one-tailed test, I would look at this value above it where it says one-sided, but notice it says one-sided PR greater than Z. So this is a one-sided increasing or a one-sided greater than hypothesis test. So in this case, this would be the p-value if your alternative hypothesis had a greater than symbol in it. If it had a less than symbol in it, if you were looking, for example, if your hypothesis was that less than 40% of people had normal blood pressure, then you would have to take the complement to this value. So 1 minus 0.04, which is approximately 0.96. So again, it depends on what you're looking for as to whether you use the value you see here or you have to subtract it from 1. Again, SAS is always going to show you a one-sided or a one-tailed increasing hypothesis test p-value. It's showing you greater than in your alternative hypothesis. But if your alternative hypothesis has a less than symbol in it, then you have to take this value and subtract it from 1 to get your p-value. All right, so that's it. That's how you conduct both a hypothesis test and find confidence intervals for proportion data. Thanks for watching.